This is the encoder video. What I hope to do is go through kind of the evolution of the project, identify where the project's at right now and where we kind of want to take it. The evolution is 10 weeks long for the most part. It started with the idea of creating technology that could support self-regulated learning practices. That is, how do we set goals, how we manage tasks, how we evaluate our knowledge. And it really shifted within components of self-regulated learning. Within understanding self-regulated learning and understanding the mechanisms of this design can affect this part of self-regulated learning, we understood that there were complex chains and mechanisms that kind of fed into each other. That is, if you want to be able to evaluate how well you know information, you might make a confidence judgment, but where does that confidence judgment come from? Well, it comes from your understanding of how well you're doing. Where's that come from? Well, it comes from evidence that you gather as you go through the system, which may come from feedback or your perceived goals of mastery. So we went from the affective of confidence to the cognitive of goal setting and understanding of mastery. And this was very much a struggle that I ran into as I was kind of understanding the sphere of self-regulated learning. And that is the cognitive, the affective, and the behavioral all interplay very closely when we start to understand how design can kind of guide and maneuver within this space. So the one big thing, I think we were doing some great progress in understanding how design can influence self-regulated learning strategies. However, we didn't really understand the characteristics that can help people learn in the first place. So that's where we started pivoting just in the last couple of weeks, where we're just like, well, let's just design a system, understand what obstacles students have and what characteristics can overcome that system. Because then if we have a set bunch of characteristics to understand a system, then maybe we can start designing for more motivation, for more effective variables that may lead, or to start designing for the self-regulated learning strategies in the first place that we were talking about. So we wanted to create a system that can teach something. So I had to come up with what exactly do we want to teach, and thought that naming and writing chemical compounds would be a good thing to teach people. And I had to have a motivation for this, and that is, I think, naming and writing chemical compounds is very much the language of chemistry, so it's used all over the place. So, I mean, even on this wonderful, yummy finals week Cocoa Puffs, we see that there's a whole bunch of words on there that might be really, really confusing to individuals. Thiamine, we have sodium carbonate in the ingredients, and sodium phosphate or ascorbate right down there. I don't know about vitamin C. But to start to understand like what we're eating, what we're like putting in our bodies, we might need to understand the language of chemistry. So this also is not taught very well in classes. There's been some charts and schematics that have shown that it just it's more complicated than one might think about just like memorizing, because that's usually what is done. Is most chemistry teachers just kind of put these words out there and hope that students naturally kind of form the rules to understand the language, and with enough practice it makes sense. However, kids could struggle if they don't have all the information beforehand. So if you just see a formula that looks complex and you're supposed to do something with this and you have missing information, you don't know how to name that formula or really understand it, then it could lead to kids struggling. And that's really what we wanted to do, is to create a system to help kids not struggle with naming chemical compounds, so then you can actually use those names to do whatever you want with. Rather than just kind of learn it through time. We wanted to kind of oust that struggle. So that's the motivation, kind of the evolution where we're at. So now we're designing a system to help name and write chemical formulas. So how can we do this? And one of the things that we're looking at is intelligent tutoring systems. Intelligent tutoring systems have been able to show that students can learn from technology to gain a cognitive skill. For example, Algebra 1 in the Lisp tutor from Anderson students were able to successfully learn Algebra 1. And in general, cognitive tutors are just as efficient as human tutors, which is kind of exciting. So let's go into kind of what I started looking at for cognitive tutors. We did do a paper prototype, which was oh so fun. And in this paper prototype, we are doing it on a mobile device because we want to make sure people have access. Like students could select what level they wanted to go to, and they could select there, and then they would start getting some lessons. Now within these lessons, we're going to teach by examples. So this is just like we're going to try this as best as possible. They're going to learn by examples, so they could get something right here that would pop up on the screen. So they look at the example, they get the rule, they start to make sense of what's going on from the picture. And it's been shown that examples actually really help students learn. It's a preferred method of learning rather than instruction. And all the while, after they get the example, they can do as many practice problems as they want. They can start figuring out like what is the charge of an ion by just doing lots of practice problems through this and so on. So that was some of the initial prototypes. What I learned through those was that one, students can learn by example just in that very simple system. You click on the bubble, you see the example, yes, you can learn, which is wonderful. It's really good to know that because a lot of digital systems don't necessarily have that, or the technology companies that I've worked for have not necessarily prioritized, like, we are going to teach. Like the one I worked for, Curriculum Associates, had said we are going to remediate. But this is a method that is actually has been shown through the paper prototypes that it can actually teach, which is really exciting. And also, though, as students move through this, one of the self-regulated learning concepts was the idea of like being agent or having agency as you move through this, and actually understanding like your level of expertise in something. And so, in the prototype, we had people continue by hitting the I mastered something. But in that prototype too, I would find that people really didn't understand, like, well, how do I know if I mastered something? Like, how do I know if I've been an expert? So again, like, we shifted away from these self-regulated learning practices because we just wanted to design a system that could actually teach someone something. So that mastered button is now gone, and we're having the intelligent tutor kind of walk through students and like kind of identify what the mastery is. And so there's a lot of components to the intelligence tutoring system, a lot of characteristics and obstacles. I definitely look at the research canvas to kind of understand where I'm coming at with those characteristics, the motivation for those characteristics, the obstacles, and that's really where we're going. Is because I haven't identified everything. I haven't justified everything. My arguments are completely sound to be paper written. But it's exciting because it's there are some very promising features that aren't necessarily at the forefront of intelligent tutoring systems, whether it's learning by examples, whether it's being on mobile devices to learn, so having access to learning wherever you want. That was kind of one of the major motivations of the project, is that like I want my students that I previously taught or any other students in those communities to have access to quality education. I went to Mississippi, and the year before me, there was a substitute teacher that just had students read the book the whole time. And then in Austin, their teacher quit on them 2 weeks into the school year, and I came in and filled. And so it's just like, how can we still get information to students that might not have the opportunity to learn something great? And that's always kind of been a goal for technology systems, and kind of a dream, is this idea that we can help teach outside of the classroom. Which actually leads me to more of the motivation for this. After some talking with colleagues, it seems like it's not just about teaching people chemistry, how to name and write molecular formulas, but it's like, what are we going to do with it once they know that? So yeah, say it's a perfect system and it works. What are we going to do with it? And so there's really two directions I can see this problem project going is really identifying the components of a really good tutoring system and saying like, well, what can we do with that knowledge? And we might need to prove that like, well, with this knowledge, then we might be more successful at inquiry-based learning. With this knowledge, we might be more successful at project-based learning. And that's really the divergence of directions that this project is going. So keep developing the tutoring system. That will probably be most of next quarter, and start designing those or creating great design arguments for the characteristics of the ITS systems, and start really kind of understanding the directions that we might want to take this, kind of laying out the path that we see acquiring knowledge and how it can help students overall learning. All the while, I think I talked about like when I tweak the ITS, we're looking at probably affective components too, because learning chemical names, how to write in chemical names and formulas might not be the most motivating, wonderful experience, and so we'll probably need to figure out what motivates them, what engages them, and paying attention to the affective part, and maybe even self-regulated learning as a motivator to learning on their own. I said on their own. I tried so hard not to say on their own in this video. Anyway, wonderful quarter. Hopefully this covered quite a bit of it. See you next year.